All right, guys, going to do my best to go through the non-calculator part of this. So we're looking at standard form and slope-intercept form. So standard form will be set up as, we'll call a times x plus b times y equals c. And a couple things on standard form. We have to make sure in this form that there are no fractions to start out with, and that a ends up being a positive number. So we'll go over how to adjust that as we get into it. And then we have the slope-intercept form that we've used plenty, which is just y equals mx plus b. So first, starting out when we've got a line already here, and we need to put it in slope-intercept form. First step is going to be to find that y-intercept, which would be the b, and then the slope. So going up 1, 2, 3, 4, 5, 6, looks like 7. So b will be equal to 7. And then for my slope, I know it's going to be a negative slope. So I'll go ahead and put my negative sign because it's going down to the right. It's going down 2 and over 1, 2, 3, 4, 5. So negative 2 over 5. Once I've got that, that is all I need for my slope-intercept form. I can just write it, y equals mx plus b. So I just substitute in the b and the m. So y equals negative 2 over 5 x plus 7. Now for our standard form, we're going to start out in the same way. So find my y-intercept. Looks like negative 1, 2, 3, 4. And for my slope, it's positive. I'm going up 1, 2, 3 over 1. So up 3 over 1, which I could just write as a slope of 3. Now I'm going to write it in my standard, or my slope-intercept form, and then we're going to change it into the standard form. So y equals slope, which is 3, times x, minus 4, because that's a negative 4. Now to adjust it around, I just need to take and move my 3x over to the other side. So when I subtract 3x from both sides, I end up with negative 3x plus y equals negative 4. Now remember I said we needed a couple things there. First thing, everything needs to be whole numbers, no fractions, which I've got, but I also need to make that number at the front a positive number. The way I do that, and you can think of it as multiplying everything times a negative 1. So doing this times negative 1, distributing it to both of those, and multiplying by negative 1, real small over here. What ends up happening is that changes to a positive 3, x, then a negative y, and a positive 4. And then we've got our standard form. Okay, looking at instance when we have the slope and the y-intercept. So I've got my m and I've got my b, but they want it in standard form, kind of doing the same thing as we did in that graph. I'll say y is equal to negative 1/2 x plus 6. So I need to add 1/2 x to both sides. And I end up with 1/2 x plus y equals 6. Now in this instance, I end up with a fraction on this side, so I need to multiply it by something that's going to cancel out that fraction for me. So to do that, to get rid of a 1/2, if I multiply this by 2, and I've got to multiply again the 6 over here by 2 as well, I end up with x plus 2y equals 12. And I'm back to that standard form. That's all we need to do. Okay, now, number 4, I have slope, and I have a point that's on the line, but I do not have my y-intercept. I've got a different point. So one of the ways to do this, since we're going to slope-intercept form, is I will start out and I'll plug in just the information I have. So there's my y equals mx plus b. Okay, so we're going to substitute in here, and notice I've got the m for my slope here. Then I also have a point, which means I do have an x value and a y value. So I can plug those in. Then I've only got the variable left for b, the y-intercept, and that'll enable me to find it. So my y value was 2 equals 1/3 times 4 plus b. So I've got that. Now I need to multiply this and move it to the other side. So if I multiply that, I get 4/3 plus b equals 2. And if I subtract 4/3 from both sides, I end up with 2 minus 4/3 equals b. Now all I've got to do is combine this into one regular number. So what I can do here is if I just take 2 and put it over, turn it into a fraction, so cut it up into thirds basically, that 2 wholes I could change into 6/3, and when I do 6/3 minus 4/3, I end up with 2/3 for b. So I've got my 2/3 as b, and I've got my slope that's 1/3. All that's left is to write out my formula. Y equals 1/3 x plus 2/3. And that gets me my slope-intercept. That's all I need right there. Okay, looking at number 5, and remember our notes from the other day on 2.1, and said when a slope is undefined, that means there's no defined slope. That's going to be a vertical line. So thinking about my vertical line, and it says it passes through 2, 4. So a vertical line is going to stay on one x value going up and down. It'll go through a lot of different y values, but it stays right there on that x2. So that line is actually just defined as x equals 2. And that's standard form. And if we thought of it as ax plus by equals c, then the b next to the y would be equal to 0. So that gets rid of itself, and we just end up with the x equals 2. Okay, looking at number 6, still wanting slope-intercept form. Now this one's similar to number 4, but it tells us that x-intercept is -16. So what that means is, if I have a graph, think about it this way. Here's my y-axis, here's my x-axis. That means it intercepts my x-axis at -16. So that means my value for x here would be -16. But when I look at my y, we know the value for y here is actually just going to be 0. So in this instance, even though we don't have a named ordered pair here, really 16, 0 for the x-intercept is an ordered pair that we can use. So we'd work it out the same way as number 4, substituting in 0 for y and -16 for x. And we should get that value for b should be 8, I believe, and then we could make our formula from there. Okay, looking at number 7. It wants a slope-intercept form, and all I have is 2 points. So when I don't have slope right now, or my y-intercept, I've got to do a little bit more work. And really, all that's happening is, like on the graph where we'd count this far up, this far over, that's all we're doing to find the slope. We're taking the formula for slope, which is y2 over -1 minus y1, which is 5, and then doing x2, which is -4, and x1, so minus a -2, or you could just say plus a +2, either works. Ends up giving me slope is -6 over -2, which simplifies out to be a slope of 3. Now once we've got that, I'll just take it and plug it into my formula and use one of these points to help me find it. So for my y equals mx plus b, let's say we use the 5 and the negative 2. So 5 equals 3 for the slope, and x would be negative 2 plus b. So that gives me a negative 6 plus b equals 5. I can add a 6 to both sides. And I should get that b equals 11. And I've got my slope there, my value for b there. Just plug it in and I've got my formula. So y equals m of 3x plus 11. And there is my slope-intercept form of that we can now graph from. Number 8, we would do a similar thing, but one of the things to notice here is that you've got a y value of 5 there, a y value of 5 there. So what I end up with is 0 over something, because doing my slope-intercept, or my formula for slope, it's going to be a 5 minus 5, so 0. And this ends up with a slope of 0. So I know, basically I end up with a horizontal line, and that line is defined as y equals 5, because it's a line that just travels along that space where y equals 5. Okay, looking at one more here, where I am going to solve through to get my standard form here. So looks like I have 3x minus 4y equals 8, and then I've got a point here that it's passing through. So to do that, I can first figure out taking this and changing it to my slope-intercept form, which gives me negative 4y equals negative 3x plus 8, and divide both those, or all of those terms, by negative 4, and I end up with y equals 3/4 x minus 2. And since it says we're looking for a line that's parallel to this one, we've got this line. I've got a slope there now. And what I'm going to do is actually substitute this, use this slope and the point that I have, and that's going to help me find my parallel line. So using my slope formula of slope is y2 minus y1 over x2 minus x1. I know my slope, since they're parallel, they remain the same. That's 3 over 4 equals y minus the negative 3, or just plus 3, and then over x minus 5. So what I can do from here is take and sort of adjust this formula by multiplying both sides by x minus 5, which gets this out of the denominator, then multiplying both sides by 4. So really what's happening is that 4 is going to travel up there, the x minus 5 is going to travel up there. So that gives me 3 times x minus 5 equals 4 times y plus 3. Work that out a little further. I get 3x minus 15 equals 4y plus 12. And then all that's left to do is for me to move this around a little bit. So take away 4y from both sides, and then I'll add 15 to both sides as well. And go ahead and do that as just one step to save some space for us. So I end up 3x minus 4y over here. And again, I'm also going to add 15 to both sides, and 12 plus 15 ends up giving me 27. And there we go. We have our standard form is what they were looking for. On the next one, they're looking for a perpendicular line that passes through this point. So the only thing that is really different for us between these two is that once I find the slope of this line, which, well, it's the same line as in number 9. So since I know the slope was 3/4 over here, the slope for my perpendicular line would be equal to 3/4 flipped upside down, so 4/3, and turn into a negative. From there, I can do my same steps, plugging it into the formula, and end up with my slope-intercept form pretty quickly.